Yeah.
Freaking out. Okay. All right, so we are now live.
Yep. I'm Mary McElpring.
Do you introduce yourself?
Yeah.
Oh, okay. I'm Maddie Darnell.
Yeah. Okay.
Cut out like right when it introduced you.
Oh man. Yeah. Sorry, I'm still eating dinner. So, but.
Oh no, you're totally fine.
Okay.
My internet's being a check. So I did. Did you watch the video, like the review video?
No, I was going to, but I didn't start it.
So the review video that she filmed was super helpful.
Mm-hmm.
I didn't get a chance to watch the entire thing. I think I watched about 45 minutes of it.
Mm-hmm.
And that's like all I got just because I was watching it on my lunch. But yeah, I found it super, super helpful. I need a bigger screen, or I need like 3 screens, I swear.
I know, I never thought I would want to. You know?
Yeah. But I feel like I definitely need it.
Mm-hmm.
What? Oh, apparently we were supposed to take this quiz by ourselves for the first time.
Mm.
Did not do that.
Okay.
Yeah, it says, remember, you should take this quiz once before you meet with your group, and then a second time with your group during group prep.
Okay. So let's take it, and then we'll talk about it.
Okay. Well, because I didn't even see this until I opened the quiz. I never saw that.
Yeah. I don't remember reading it either, so.
Yeah. Let's see. Gosh. I just realized I have no paper. Use my planner. Oh gosh, dogs. Stupid dogs. No. my goodness. I don't know if you can hear that. Mm-mm. Oh my gosh, this one is so long.
Wait, I feel like I have such a hard time using the ones where you have to like use the software for it. Like the mean. Like I know how to do a mean. I just don't know how to do it with this one.
With like the software?
Yeah, so like with Excel, how you calculate the mean.
So it's that, remember, you get it off of the, I know mine's saved in my computer, but it's the, you know, that formula worksheet we have. Remember, and it finds everything for you.
I feel like I knew what you were talking about, but I didn't know how to do it myself.
Okay, I can show you
Okay.
like what it looks like. Oh my goodness. Oh my goodness. I really hope you can't hear all of the noises going on the computer right now.
Oh, I can, but it's fine.
Oh, I'm so sorry.
I'm really gonna have to figure out how to do that, the standard deviation, because like I feel like there's a lot of things that I haven't downloaded yet, so I just
Yeah, we can go over all of these because I feel like yeah, there's about this because okay, so she said there's going to be 38 questions on the test.
okay.
And it seems like and it's only available till tomorrow.
Yeah.
So it seems like there's going to be the exact same amount, and it's probably like all similar questions.
Yeah.
This is the meter to come to, and she said no. Because I'm sure everybody was asking her to come to this one.
Yeah. I'm doing homework right now. Sorry. This is
This one. It's this one. Yeah, that's tell you. Okay. So I'm looking at question 19.
Mm-hmm.
And one that asks you about like estimate the mean. But it gives you like those weird.
Yeah. I'm not there yet. I'm still stuck on the later chapter. But this
That's okay. I skipped a couple of them.
Yeah, I feel like there's so much I forgot.
Well, yeah, because like if you don't do it every single day, which we obviously don't, we do it twice a week. Then it's easy to forget them. If you want, you can just go over them together.
Okay, yeah, let's do that.
Because there's 30 questions.
30, yeah, that's a lot.
Yeah.
So this one, the mean.
So, oh gosh, dog, computer. Oh my goodness. Also, there is not homework.
No.
Yeah, they faked you out, and they were like, homework and exam info.
Yeah, nope, psych.
I know. I don't know why they did that. Oh my goodness.
Okay. So on 19, they want to know the mean.
So we can go back up to the top, and we can just like work.
Cool.
Oh, I almost just started the actual exam.
Oh, man. Yeah, that's scary.
Yeah, I'm not ready for that.
No. Okay. So it asks which of the following variables are categorical. I put the last two because they're the two that seem different from the first one.
So let me go back to my notes. So in the video that she did like the review on, she said, ask yourself these questions. If either of them the answer is a no, then it's going to be categorical. If either of oh my gosh, that was my dogs. If either of the answer is a yes, then it's going to be quantitative. So the first question is it a number? And if your answer is yes, then it's going to immediately be quantitative.
Yeah.
So that was, and then she talked about if the age one, because she said that one's really tricky. So I think that it's only going to be randomly selected brands, because I thought about the age one and I was like, but it's still a number. They're still asking for, yeah. See, that's the hard part.
Okay. Okay, and then for question 3, I put that 100 is the parameter and 112 was the statistic.
Yeah, that seems right to me.
Okay.
Because The parameters are numbers that describe the populations. The statistics are the numbers that describe the sample.
Yeah.
Okay.
Um.
Next one, I put that it was a stratified sample.
Yeah, I think that's right. I was thinking either that one or the cluster. So yeah, I think it's stratified.
And then for number 5, I put that it was a cluster.
Yeah. Okay, at a school fundraiser, I put simple random sample on 6, but it can also be systematic. Is it simple random?
I think it's simple random.
Yeah, because systematic would be like every other or something like that.
Yeah.
Okay. For question 7,
I said a stratified random.
okay.
Oh, I should.
And then for these ones, I just don't know how to work. I'm gonna go.
I can do this. Okay.
Yeah.
Okay, and then it downloads. Oh my goodness. Oh my goodness. Okay, if you want, I can, like, screen is just a mess right now.
Yeah.
Okay. Basically, I really hope it doesn't take the iCard, because that's not what I want. Okay, I'm gonna use.
You select them all, and
then you go over to the quantitative descriptive statistics. And then you go here, and then you Control V.
wait, where did you get the quantitative? Is this something you download?
This guy is downloaded on my computer. If you want, I can, like, email you the file.
Yeah. Yeah, that would
Yeah,
be really helpful.
Yeah, because then it calculates everything for you.
Yeah.
And you don't have to worry about anything. So for this one, it was asking for, I believe, the mean, so it's just 4.77.
Okay.
4.771, because it's to the third.
Yeah.
Yeah.
Okay.
And then number 9 is asking for the standard deviation, so it's 1.912.
Okay.
And then what's number 10 asking for?
It just asks you if you created a histogram.
If you create a histogram?
Yeah.
Oh, I think this is basically your histogram right here.
Yeah, I think so.
Yeah. What did I say for number 8? 4.771. Oh my goodness. I can't remember what right now. 1.912. Oh gosh, I wrote 11.1. And then 10. Scroll for creating a histogram of the amount spent in possible purchase. Then mark the following statements. I created a. Oh, well, yeah, we did. It's right there.
Yeah. Okay. With question 11, is the X with the line over it, is that the mean?
No, mean is you. It's like the.
Oh yeah. So then what is the X with the line over it? I couldn't remember.
Oh, that's a good question, actually.
Because I remember that we knew what it was, and that we found out what it was, and we were like, oh, it's this. But
sample mean.
Sample mean.
Yep. In a statistic. So it's 37.91 minus the sample mean. So I think we can get, how do we get sample mean? How do we get that number?
Would you add them all up and divide them to find the mean? Because I think that's what I did.
I think we can use this guy.
Yeah, I think that's actually what you're supposed to do.
Yeah, that's why I like this guy. And then I'm really sorry if you can hear them, like, not growling, but, like, playing in the background.
It's okay. Dogs are dogs.
Don't want to stop. 3.16. Okay. Alrighty. So that gives me a mean of 38.075. So then if you take the x, which is 37.91, and you subtract it by, so deviation from the mean. So x minus the sample mean. So, what's this one? Oh, my phone. There you are. Okay, so I'm going to take this. That's my flashlight. Okay, so you do 37.91 minus 38.
0.165, right?
Numbers this 11. I mean, yeah, that sounds right to me.
Okay, yeah, because I did this by hand. Like, I didn't input it, but I did the mean by hand.
Yeah, I mean, it sounds right. It says round your answer to 3 decimal places. Yeah, I mean, that's, well, it's technically negative 0.165, but you can't put a negative in there. So I'm going with 0.165.
Okay. And then it asks what the value of the number that goes in the position marked with B is. So that's
37.
It would be the same thing squared.
Minus 38.075 equals, and then we're going to square that. 0.680. So 0.682 because we're rounding it up. Or actually 0.681.
I had 0.680, but what was the number after that?
6. So 0.6.
Oh, yeah. 81. Yeah. Yep. Okay. What quantity is equal to the sum of numbers in the square deviation column? I
want you to find them all out. Why?
No, they just want to find the quantity. Yeah, I guess.
Oh, so it just wants to know, like, what would it equal? So it's not equal to mean. It's not going to get that high. The standard deviation is 0.715, so you know it's going to be more than that. And the variance is 0.511, so you know it's going to equal more than that too. So it's none of them.
Okay.
Because you know it's not going to be the mean, because the mean is 38. It's never going to get that high, because you know it's going to be decimal points.
Yeah.
No matter what, it's either going to be decimal points or negatives.
And then the standard deviation is even less than that. How do you find the variance? What is the variance again?
It tells you. Can you still see my screen?
Oh, yeah, I can.
Yeah, it tells you right here.
Oh, okay. Yeah.
That's why this like little document thing is super, super helpful.
Yeah, I'm going to have to like download that because I will need it.
Oh, we haven't used this. I'm sure this is in like our next unit.
Yeah.
Plots. Okay.
What is the standard deviation of these temperatures? So
0.715. So I think it's gonna go. Nope, it's just 0.715 because it's 0.7150. Okay.
Under certain conditions, the standard deviation can be negative.
No.
No.
Never be negative because then it would go backwards.
Yeah. In the same study, the researchers placed thermistors, temperature sensors, in the 3 seals named Chick, Starburst, and Pat.
What are you chewing on? Oh no! No! Bad. Sorry, he's chewing on my backpack.
Bad dog.
I know he's a corgi, so he's very mischievous.
Oh. Corgis are so cute.
He's very cute. He just has his moments where he's like, "Stop it! What are you doing?"
Yeah.
Okay, so which location is the most consistent temperature measurements from one seal to another? Well, okay, so if you look at arterial and you look at hepatic sinus, those have the biggest jump between the standard deviation. Okay, stop. So it looks like extradural keeps the closest between the mean as well as the standard deviation.
Yeah, I agree.
So I'm going to go with extradural because it keeps to the closest. I'm not trying to print this page. I promise. Oh, this should be easy. So the third quartile is 8.
Yeah.
What is the percentage of data that lies between 4 and 8? Okay, so I like took a note. Oh, you can't see that at all. Can I zoom? Can I zoom on this? I can make it bigger. So there, now you can see. So if you can like turn that sideways, this is what she showed in the video. So I like copied it to my notes. So basically, I think last time what we did was definitely right, because I know we struggled when we were like, this makes no sense. But basically it's 50%, because that's what we did last time, remember? And we kept getting it wrong.
Yeah.
Yeah, so that's why I got really frustrated, because I was like, that makes no sense.
So they want to know what the percentage of the data is.
Yeah, so it's 50.
4 and 8. Yeah. Wait.
Yeah, because if you look at it this way, this is just like vertically.
Yeah.
But it's 50.
Yeah, because it's the... Makes sense. Oh, okay, this is the stuff we were doing last time.
Yeah, this is the stuff I was stuck on. I was like, I don't know what that is.
And I felt pretty okay with it. I need to take better notes. I like do my homework and then I don't take notes.
I took the notes on like the notepad on my computer.
Yeah. Oh, okay. Yeah. Okay, so the mean is the U, right?
The mean is the U, and then I have a little note right up here.
So the standard deviation for this problem is 2? No.
So it says an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm parts per million are considered a health risk for infants less than 6 months of age. City of Rexburg reports that the nitrate concentration of the city's drinking water is between 1.59 and 2.52. And values outside of this range are unusual. We will assume that U minus 2 to the standard deviation equals 1.59 ppm, and U plus standard deviation equals 2.52. It is reasonable to assume the measured nitrate concentration is normally distributed. Estimates mean of the measured nitrate concentration in Rexburg's drinking water. Yeah, I have no idea how to do this one because it doesn't give you the values. Well, I feel like you would solve for the z-score, but how do you solve for the z-score if you only know it's a backwards z-score?
Yeah, because this is the z.
Yeah.
No, sorry. Yeah, it's the x. Yeah, the z-score.
Yeah, it's a backwards x. Yeah.
So would you put the z-score in the applet and then get the, where's that?
I think so, and get the area.
Yeah. Okay.
Oh, usually it tells you to use the applet, but oh my goodness, Winston, why? Okay, so go over here to normal probability.
What would the answer? So is the area the same thing as the mean? Because I feel like it's not.
I'm trying to remember because I think this is the part that I didn't get to. She was just starting on it.
Yeah.
And that's when I was like, oh, I can't.
Yeah.
Problem like this, where it's like backwards.
Yeah, I remember that it looks like it's backwards. You know,
yeah.
They already have the z-score. I'm trying to find. Can I search on the textbook? I can. Z-score. Except the only interesting thing about this is that, oh no, it's the same because the 2 would be, yeah.
Unless it's two, I'm trying to like figure out how to separate it. So a normal z-score is z equals x minus standard, no, that's mean. So x minus mean over standard deviation, right? Yeah, so
yeah, if that x, yeah, I think so.
Yeah, so if you're doing it, so maybe if you put x on the other side.
Because I know that you move them around a lot.
Yeah. I'm just not sure how to solve this.
Oh, wait. Okay, because I feel like I know this. Like I know this. I just can't remember.
Is the area and then this one? Oh, because of these words. Area is 0.017. Right?
What are you doing? Which one?
I'm messing around with the z-scores.
Okay.
But I feel like it's not right.
Because the area.
Okay. Minus 2. Let's see. If I. This is weird. Show math as. Wait a second. Math ML code. What? I don't know what I'm clicking on.
Where would you shade? Do you know?
Yes. So it says. Because it tells you less than 6 months of age. So, your sample size is 6 months.
Oh, I did not see that. Okay.
Yeah. So it gives you a sample size of 6. So wait, so 6.
Six months.
And oh, that's why it says that. So an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean.
Okay.
And so it's saying that nitrate concentrations above 10 parts per million are considered a health risk.
Because it's more than 2 standard deviations from the mean.
Right. So that's why they're doing. So they're looking for a concentration of the water supply in between 1.59 and 2.52. So that number has to be in between those two.
Okay. So would it be on the higher side then? Because like when you shade the applet, would you shade less than? So would you shade the left side?
Would you shade the left side? Well, it's hard.
Yeah.
Looking for. Oh, wait a second. Do you put? Oh wait. Does the z-score on the left side have to be the same on the right side? I forget.
It ends up being the same.
Huh?
I think it ends up being the same.
No matter what.
Yeah, because like if I fill in 1590 on one side, it's going to be negative and then the positive one.
Okay, because I was going to say, if only you could put them both in.
I know, it feels like the easiest thing to do, but you just can't.
Do you want to come back to this one?
Yeah, let's come back to it. I feel like we're close. It also wants the standard deviation of the measured nitrate. So we'll come back to that too. And also number 21 is for that one as well.
Mm-hmm.
Okay, so then it's asking the admission committee for most Masters of Business Administration programs. This test has been shown that the scores on the GMAT are normally distributed with a mean of 50.
It's not the 68, 99, 99.7 rule, is it?
I think it is.
Extreme numbers that are not beyond the bell curves are not extreme. Anything beyond 2 or -2 would be considered unusual or extreme. Numbers that are outside the bell. No, that didn't. Yeah, I don't know. Extreme or unusual values. Nope, that's what I thought.
Okay, 99.7. So then if your mean is 53 and your standard deviation is 120.54. So then you just subtract and add where is needed. So 542.3 subtracted by
For 22, I got 0.5.
Okay, how did you get that?
So if you do the z-score formula,
and
then you do, it says, so then you need to do above, let's see, here's back. Equals x, which is, the way this last part is worded is really confusing because you feel like it should be accounted as part of the problem, but I don't think that it is, where it says the minimum GMAT score required for the admission to MAC program is the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. Because I feel like that's not necessary. That's just confusing.
Well, the thing is, I want to know what they're asking exactly, because I feel like this could be the 65, 68, 95, 99.7 rule.
I think it is. I think you have to draw it out, basically, because you have the 54.23 as a standard deviation, and then you have the 120.54, and then you have your x, which is 54.23, or 542.3. So.
Yeah, okay, so.
And then you need to solve for your z-score, put your z-score in, and get your area.
Yeah.
Because you have your value, and then you need to shade to the right because you're going above. Does that make sense?
Yeah.
They confuse you with that little bit. That's why I was like, that makes no sense. Why would you even?
Wait, so finding the z-score from this, would you put the mean over the standard deviation and be done? Or, because I feel like.
See, that's confusing, isn't it? Because you're subtracting the same number.
Yeah, and I feel like you should have
mean over standard deviation. Let's see. So 542.3 and the standard deviation is 120. Well, so you have 542.3 subtracting by 542.3, and you have 0 divided by 120.54.
What? Sorry.
Well, okay, so your mean, your x is your value, so 542.3. minus your mean, which is 542.3. You've got 0, which you're dividing by your standard deviation, which is 120.54.
Yeah, I think that the
is 120.54.
I feel like
I don't think you can put in a number that high.
Yeah, I don't know.
You can, but the area is insane.
So
I feel like there's a step that's being missed because okay, let's see.
I'm just trying to figure out the
oh, because it's random.
So
remember, there's always something weird when it's random.
Yeah, but I don't.
I also don't remember why. Okay.
Random. This is terrible. Why? Okay. Randomly.
I have to take the exam tonight, and I'm gonna die.
Are you taking it tonight?
I have to. I have work all day tomorrow.
Oh my gosh! Good luck.
I know, right?
I will pray for you.
Thank you. Thank you.
Yeah. Because that's the only way to get through math class is prayer.
It really is. That's it.
And tutoring. Tutoring is like saving grace.
Yeah. It really is.
Randomly select. Okay.
At this point, your brain's fried, and you're like, well, why do I do this anymore? You know what I mean?
Yeah. But the thing is, like, I'm so bugged because I feel it like it's on the tip of my tongue, like it's there.
Right. Well, that's why I really wanted to have the tutor at this point or at this meeting because I was like, I know it's going to be so easy, and we're going to get so mad because we can't. Oh wait. See, I get confused because I don't know if it's.
Wait. What if selected score above? What is the range?
What if it's this guy? Wait, am I supposed to be using this one? No. Okay, no. That's not the one I'm thinking of. There's like
So I'm kind of curious. What if it's
remember that weird one that like takes forever? That you like tap and all the cubes fall?
Yes.
I never know when to use that one. So what if this is the one you're supposed to use that
one? I don't know.
No.
I'm kind of curious. I tested something out. I don't know if it's right. But I was looking for the z-score. Mm-hmm. And what I did for this time is that because you have the values 500 and you have 600. And so it wants to know the score above 542.3.
Yeah.
And so I did the 600 one. And I got a z-score of 0.479. But I wonder if you're supposed to do both of the z-scores of both the 500 and...
Oh, so if you put in 500?
Yeah, as the x for the standard deviation.
Oh, okay. Yeah. So then what if you do the 500 and the 600 and you subtract?
I think that's what it could be. So this was from the 600. This was the 500 one. It was 500.
Nala Winston, I'm gonna kick you off this couch. But then you have
a negative. Well, if you subtract them.
I really wish that she would have put like this is from lesson something and something.
Mm-hmm.
We could have referenced it at least like in the online textbook. That would have been really nice.
Yeah. So I got 0.128 from subtracting the z-scores of both of those.
Mm-hmm.
And so I'm just gonna plug it into the applet and just see, would it be the area? Then if it's shaded right.
0.728. 0.728.
For
oh, and then we do it right because we're doing above, right? Or are we doing?
Yeah, it's above 54.23. But I'm not sure if this is right. Like it seems like it goes together, but I'm just not sure, you know?
I don't know. I wish that there was a way to like Google the question and have somebody work it out for you.
I know.
I can try it. Let's see. What did I do? Okay. Scary. All right, let's see. Hopefully I don't have to type this entire thing. Administration. But will it show me if it's like worked out? Oh gosh, all it's pulling up is MBA program. Oh wait, chegg.com. I don't have chegg.com. Oh, there's like all the questions, but I don't. Oh gosh. Oh my goodness. Oh wait, here it says. It's so small. It just says P. I don't know if you can see that.
Yeah.
X something. Equals PX. I don't want to pay to see the full answer, but maybe that can help us like set it up.
Yeah. Okay, I'm going to.
You were right. So it was the original z-score formula.
Yeah. So
it was px minus mean over standard deviation, which was 54.2 or 5. I don't know why I keep saying that. 542.3 minus 542.3, which equaled z. Oh, but you know what we did, which was a mistake? We put the equal sign in it. It shouldn't be the equal sign. So it was z is greater than 0. And then we needed to input x somewhere. I need like the full answer for this. Can someone give me a full answer? Okay, I don't understand how they got this. So do you see what I'm looking at right here?
Yeah.
Okay, so see how they have px. So I see how we did this a little bit incorrectly. So it was like, but we set it up correctly, but how did they get 0.5?
Hold on. The only way to figure it out is to do what they did. Yeah, I don't know how you 0.
Because it seems like it's just popping out of nowhere.
Because it would be a 0 on the top, realistically.
Yeah, because it's 0 over 120.54.
Okay, I'm plugging it into my calculator.
Unless we did something inaccurately with like solving the parentheses, because remember how she said something about the parentheses?
I don't remember.
I don't remember either. And then we have Oh, wait. Oh, it's the parentheses. So see how it says px is greater than 542.3?
Mm-hmm.
So I think you do like this equation. So I wonder if you plug this equation into Mathway, if it'll solve and get this.
I wonder.
Yeah.
Okay.
Although I feel like we never learned this. Is that just me?
No, it's not just you because the middle looks familiar and
Like this part, the z-square formula looks familiar, but this doesn't look familiar at all.
no. I don't know what
Yeah, I wonder if I plug this into Mathway, if it'll solve it and get 0.5.
Yeah, I don't know. I'm
After
trying to plug it in.
pulling that out of a hat. Here, if you guys can solve this guy. Solve for P. Let's just say evaluate. Nope, they said nothing further can be done with this problem. Solve for P.
I got 0.
Mathway can't solve it the way they have it set up.
Okay.
Oh, so let's say solve for Z. Nothing further can be done. Yeah, I just don't understand how they got 0.5. Like, am I not doing this right? I don't know.
I don't even know.
Well, and they're putting in the different values. I just want to understand how they're doing it. So,
yeah.
Like, this one makes sense because they're going to get a number, be able to divide it by this, and they're probably going to get this, and then, but still, then how do they get this?
Yeah, I don't know.
Because you can't divide 0 by 442.3 and get 0.5.
Yeah. Yeah, you can't subtract something and get a value, the same values and expect to get a different value in the end.
Yeah, see what I mean? Like, look at this one. What?
Yeah, that makes no sense.
Yeah, I wonder if we put in 0.5 if it's going to be right, but like at the same time, I want to know how you do it. Oh, wait a sec. Is this like you can see that's going to explain it to me? Nope. I just tell you. Oh wait, does the standard deviation have a point in this?
Or what if it's just the 5 for 2.3 over 120.44? Because if there's only one value, there's no way you could.
Yeah, well, it's just frustrating because I feel like I never learned this, and like, if I'm going to be tested on it, I'm not going to be able to do it.
Yeah. So I did it without subtracting it by the mean twice. So it's 542.3 over 120.4, and I got 4.4989. And I don't feel like that.
Well, I think it's 0.5 because that's what all of those other answers said. But at the same time, like, how did they get 0.5?
Yeah, I don't know.
I don't know either.
Okay, and then
I'm just gonna put 0.5, but I don't like doing it.
What if they use the applet and that's how they got 0.5? No, I know exactly what they did.
What did they do?
I think. I'm guessing. I'm going on the biggest limb ever. So I put the z-score. Remember how I did solve the z-score and I put the 600 and the 500?
Mm-hmm.
And then I subtracted them and I got 128. And then I put it into the applet. And for the area, I got 0.449. And so if you were to keep rounding it, the 9 would round the 4 to 5, and the 5 would round the 4 to 5.
Mm-hmm.
So it would be 0.5.
Okay, explain that again, but do it with the next one. So.
Okay, so with the next one, I think, okay, so below. So the z-score for that is 0.479 for that. And then they want to know below. So I think it would be 0.3.
So instead of plugging in the 542.3 is x, you're plugging in 600 as x. And so the z-score, plugging in the z-score, getting the area, and putting the area in as the answer.
Yeah, that's what makes the most sense on how they got that answer.
Yeah. Okay, that makes sense. So you got 0.6836.
So 316, yeah. So I don't know if they want just 0.3.
I would say 0.684 because I think we're rounding.
Okay, but the thing is with the area, it's 0.316.
0.316?
Yeah, because so for the z-score, it's 0.479 for the 600 minus 542.3 over the 120.
Yeah, that makes sense.
I put the z-score in, and that was the area shaded lower because it's below. So
okay.
That makes sense. Yeah, so I'm gonna put 316 because I don't know. What is the probability that a randomly selected student will score 600 or above? So then when you just shave the other side?
Will score 600 or above? I think it's the middle and the...
Oh, yeah. Okay, so 0.684. Find the GMAT score that responds to the 10th percentile.
Oh, wait. We have to do, for the 10th percentile, don't you put in the 10, you find the z-score, you put in the z-score at the end, solve for x.
I think so.
Yeah, because you put in the normal probability applet, you put in 0.10.
Yeah.
Where do you shade though? Because you got to shade first.
Talks about the 10th percentile.
I have those notes, I just don't know.
I feel like it would be shaded the right, but I'm not sure.
Let's see.
No, because wouldn't it be shaded?
Well, middle is between, left is if it's a negative, right is if the mean is a positive.
Yeah.
So the mean's a positive, so we're going to shade to the right. So 0. I did not shade.
So it's
After I just said 1.282.
Wait, how did you get that?
So in the normal probability applet, you have to type in 0.10 because it's 10, not 100.
Yeah.
And then you get 1.282.
Oh, okay.
So
yeah.
Then so then you plug that in for z. Oh goodness. So then you do 1.282 equals minus n over.
Oh, are you solving it for the opposite? So like you already have the z-score, so you do everything else? Mm-hmm. Okay.
Yeah, I think. Well, because that's what you do with the percentile.
Yeah.
I have it written somewhere. I just don't remember where.
I know. I feel the same way.
Yeah, I need like a binder.
Oh, because the z-score is. Oh, okay.
Does that make sense?
Yeah.
And then I don't know what your x is going to be though, because there's so many different variables that it could be.
Yeah, I feel like, so the mean would have to be 0.10, right? Or 10.
Your mean? No, I think it's 42.3 because that's the mean of the original problem.
Okay, yeah.
I think you're that because you're solving for the 10th percentile, so I think that's what it is. It's going to be a negative. But then once you divide it by the 120, 120.54, I think you have negative 532.3 divided by 120.54. Losing my phone. Well, it's a goner. I don't play right now. Leave me alone. Oh wait, no, because you're solving for x. You don't have x.
No, you don't. I did that because I was like looking at the numbers and I was trying to figure out like what we do with them. And I put the z-score on the left side, and then I put x minus 542.3 over 120.54, and then I got negative 4.49.
42.
I think I'm gonna try this again.
I'm on.
I don't know why this should be negative, honestly.
Okay, so x gave me 696.83, which I feel like is inaccurate.
Okay, so I redid my math, and I got 450 even. What did you do?
So I did the 1.282 equals x minus 542.3 because that's the mean.
Yeah.
Over 120.54.
Yeah.
And that gave me 696.83.
Yeah, because I did the same, and it gave me 450.
I did mine on Mathway.
Oh, okay. Because I did mine on Mathway the first time, and it gave me a negative, which was really weird, and then I just did it on my calculator. Sometimes I like doing it on the other one just because it helps with, like, writing the formula down.
Yeah, so maybe I'll try it. Let's see. If I just did...
Round to the nearest whole number, so it would be 5.
So if I just do x minus 542.3 over 120.54, and let's see if that can solve. I'm going to solve for x. Simplify. Holy bonanza. I didn't like that.
What happened?
It's an insane number. It's like 0.00829,600x minus 4.498.
Wait, is this the same one that we just did?
Yeah, but I did it without doing the subtracting.
Yeah. Man.
Okay.
Yeah.
Why is this coming out so crazy?
I don't know.
Well, and we did the percentile right.
Yeah.
Unless there's... No freaking clue.
So would we do the same with the 90?
With The 90? Yeah, let's try the 90. Let's see if
Yeah.
that's a little bit more believable.
So it corresponds to the 90th percentile.
Mm-hmm.
So
Try this guy. So it's going to be, the area is going to be 0.90. So maybe it's where we're shading.
I think so. I think where we're shading has a lot to do with it.
Wait. Is this the 66, 99, 99 point, or 66, 98, 99.7 rule? Because when I did 0.90,
then the 10th percentile would be,
yeah, because before didn't change.
yeah.
Does that make sense?
Wait, what didn't change? Oh, yeah. The number wouldn't have changed if we still used the same, the 90th as well. Because you would be using the same z-score still. Because, yeah.
Yeah, then that number's going to stay the same.
Yeah, exactly. So.
Yeah, then something, missing a part of it. Oh, okay. So if it's less than, okay, so steps to finding a value given area percentile. If needed, click on the area with normal distribution curve. So the only area shaded in blue is on the left side of the line.
So you only see it on the left?
So yeah, because it's less than 50%, remember?
Yes.
Yeah, that's why. So type in percentile box in decimal form in the area box. Use the z-score formula under the left red line and put into the formula x equals u plus z times o to find the value of x, which is the percentile you're looking for. Does that make sense?
No.
Okay, so that makes better sense. Okay, so the reason it was wrong was because we had the wrong part shaded. We need to shade the left because it's under 50.
Oh, okay. Okay. That makes sense now. Yeah. So then, would the z-score be negative?
Number, it's 1.282. Didn't change for me.
Same for me.
Yeah, so let's see if the formula is any different. So x equals,
if the z-score was negative?
2.3. I'll bet you that makes a difference.
It should, because it would change the way that you do your math as you carry the other one over.
Well, and remember, he said that your decimals make a really big difference too. Times O, which is 120.54. Okay, now let's see if Mathway can do this one. Plus negative 1.282 times 120.54. All right, solve for x. X is 387.7677. So you'd round it up. 388. Yep. That sounds much better to me.
For the 10th percentile?
Yep.
Okay.
But I don't know how to do it if it's over that. So I don't think you do it the same way. I think you, or maybe you just shade to the right.
I think so. I think you would shade to the right.
Yeah, hopefully you don't have to do anything else because I don't know how to do anything else.
I'm so confused on how we got that number. What did you do again?
Okay, so I used the formula. So the formula for that guy is x equals mean plus the z-score in parentheses. You have to do the parentheses. That's really important. So mean plus parentheses z-score times standard deviation.
Okay.
Yeah.
Okay, that makes sense.
But it's really, really important you do those parentheses. But I find that formula a lot easier than trying to do the other formula.
Oh,
like trying to work it
the right way. You subtract it in the.
Yeah. Okay. You know, we don't get along very well. Okay, so 0.90. Did not shade to the right, so probably should do that. 0.90. Unshade the middle. Yeah, if you shade the middle, it doesn't even make a difference. So still 1.282. So where does the difference come in? Because there's got to be a difference, otherwise it's going to be the same exact number.
Yeah.
How to find the value when given the area or percentile when the percentile is more than 50. Okay. Computing percentiles. Here we go. Let's see. X equals U plus ZO. To compute the 90th percentile, we use the formula X equals U plus ZO. We will use the standard normal distribution table, except that we will work in the opposite direction previous that we started with particular X. So we use the table to find the probability. In this case, we want to start with a 90th percentile. So here's my question. The z-score is the exact same.
Yeah.
With the mean and standard deviation, respectively, we can go to the table, find the value of 90, and here exactly the value of 8.9 correspond to the z-score. Yeah, so you don't do anything different. It's the same. Yeah. Because the 90 doesn't really come into play, so I'm just worried because, oh, but it's positive. That's how it's different. It's positive. Okay, all right. That's how it's different.
Wait, oh, because did you put a negative z-score in the other one?
I did indeed.
Okay. That makes a world of difference.
Sure does.
Okay.
Gosh, that took me way too long to figure out. Does that make sense to you, though?
Yeah, so what you're doing is you're putting the z-score in, and then but how are you getting, because standard deviation?
You want me to show you my screen? Would that be easier?
Yeah.
Okay.
Because I get it, but I don't think I get it yet.
Oh gosh. Here we go. There we go. All right, there we go. Okay, so let me get the number first. 542.
Oh, okay, yeah, because you're using the one from the how it explains the problem.
Uh-huh. Yeah. Oh, I did this wrong because I was like equals. This should be a plus sign. That's why.
Okay.
Yeah, so this is right here. I don't know if you can see this. This is how I wrote it out. But basically you do X equals mean plus Z times O. So I guess you can use this for both. The real difference is going to be the negative and the positive. That's really it. So if you find the z-score for one, you found the z-score for the other one.
Yeah. Okay, this makes sense now.
Yeah.
That's what I thought. I just wasn't sure.
42 plus. Yeah. Oh gosh, that makes me feel so much better. I was like, why doesn't I don't understand it? 120. What? 54. There we go. Okay, 696.83. So 697 because we're rounding up.
Yeah.
All right, that makes so much more sense. So 697.
Okay. Find the first quartile of the distribution of the GMAT scores.
Oh my goodness, I don't know. I have no idea how to find the first quartile. I don't remember how to do this.
I feel like I should know.
Oh wait, the 16, 8, 99, 99.7 rule.
Yeah.
The quartiles?
I think so. Because
so our tutor taught me how to do this. I don't remember any of it. She taught me it and I don't remember it at all.
Okay.
Yes. Okay. I'm gonna plug in my laptop.
Okay.
Let's see if the internet has it, because that's how I found this one. Oh wait, would you just solve for 25%?
Maybe.
Because that's
for the first quartile, yes. And then wait, yes. The first one is 25 and then the next one is 75.
Yeah.
Yeah.
Is that what you would do?
Yeah, I think so.
All right, let's see here. So 0.25. And we're shading to the right. So it's 0.674.
So that would be 1. Right?
0.674.
Because it says find the first quartile of the no, because we're doing the formula for this.
Yeah, I think you still have to plug it back in.
Okay, yeah.
0.674 times 120.54. Because technically you are finding a percentage.
Yeah.
So x equals 542.3
plus
0.74 128.54. I got 623. So 624 because there's a 5. Does that sound right to you?
Oh, 623.
0.54. For this is 27?
Yeah, so 624. That's really high for a first quartile.
So I'm wondering if it's the opposite or if you should be shading because it's 20.
I think so, because if it's I think that
5 is the third. So I wonder if it's the last, like the remainder, and then this is the one, like 27 should be.
Or maybe it'll be different once you do the other one.
Let's see. Here, I'll write that number down, and then I'll see what the other one is. So,
or would you want to do a negative for the first quartile and then do the positive for the third?
You got a point. Oh, because it's negative 50. It's less than 50. So it's a negative.
Yeah.
Right, you genius. Okay.
So then 624 would be 28. Right?
Maybe. Maybe. I don't know.
We're on to something. Okay.
We're on to something. We'll figure it out yet. Negative 0.674 times 1.54.
I got 461.
Yep. Same thing.
Okay. That makes more sense for it to be the lower quartile.
Yeah, that makes much more sense because you're under 50. Remember that rule? So if you're under 50, you shade to the left.
Yeah.
because you're underneath that x-axis.
Yeah.
The third quartile is going to go to the right. So then we're going to go back to the applet and we're going to do 0.75, not 76. And that's going to be 0.674. Yeah, 0.674.
So would it be the same, just positive?
Yeah, it's going to be that number, that 624.
Yeah. Okay. Consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution sample mean scores for all such samples?
It's that formula, remember?
Yes! Oh, I love this formula. It's basically the same thing.
But with the thingy in parentheses. It's like O times X in parentheses, isn't it?
It's the... I think this is the one where it's you have 3 lines, so it's like the mean.
I think I might have this written down somewhere right here, maybe.
X subtracted by the mean over the standard deviation, which goes over the square root of n, which is the sample size. Yeah. So then, what is the mean of the distribution of sample mean scores for all such samples?
1 square root of n is on the bottom, right?
Yeah. So what was the standard deviation again?
120.54. This is a long question. Like that goes all the way through to the last one.
Yeah. Okay, so then the mean would be 542.3, but what would be on the other side?
On the other side of the mean? The z-score?
Yeah, maybe.
We found so many different z-scores, I don't know.
Yeah, I don't know. The way I'm more comfortable with it, this kind of problem is different from the one that you were showing me, the one that's like this. The one that we just did on those other two. But the one where it's divided. So it's basically the same thing, but it just looks different.
Let's see if I can find it. So it's the distribution of sample means formula?
I think so, yeah. Because it's the first variable minus the x minus the mean over something.
Oh, it's this thingy!
Oh, it is.
Yeah.
Huh.
I have a link to that. I do. I love it when I do this. Okay. To the actual book.
Yeah.
Then I can find the formula super easily. Oh, so much math for one night.
Mm-hmm.
What is the distribution of sample means? Just give me the formula. Oh, standard deviation of the sample means is O divided by N. Now where's the formula? It doesn't tell you. It just says the mean of the sample is U. The standard deviation of the sample means is O divided by N, like square root of N.
Yeah, and that's the bottom part of the...
Yeah, and I think you just put the X over U on that.
X over U.
Mm-hmm.
I thought it was
X minus U.
Yeah, yes. That's what you do.
Yeah, so you do O divided by... So it's...
So it looks like...
U over O divided by...
Yeah, so it looks like that. Right?
Mm-hmm.
Yeah. That's what I thought.
Yep, so then you just need to plug in those numbers. Oh my gosh, there's so many tabs open. So X is, no, we don't have a value.
I know. That's what I'm confused about.
Shoot, I don't know. Well, I guess we plug in what we do know. So that, oh, I guess you don't necessarily need a value.
No.
Yeah, I mean, I can do it based off the mean, which is the 542.3.
Yeah. Okay.
Over. Also, there is no square root for 15.
What is going on?
Let's try it just like that.
So I plugged it in and I got 1.16161. That goes on for.
So 542.3. Oh gosh, how did that 3 get over there? 542.3 on the bottom. 120 point.
No, you know what? So I looked it up on one of the pages that gives you all the answers. We're thinking about it too much. Remember how we did a couple problems with the tutor and she's like, you're thinking about this too much. They just,
oh yeah, and it was just the standard deviation.
Yeah, this is just the mean because it has the mean written down as 542.3.
Yes, because it puts in what is the mean of the distribution of the sample mean.
Yeah. And then the standard deviation
120.54.
Yeah, I think so. No, because remember we were doing this with the tutor again, and then she was like, no, you have to think a little bit more. Because we thought that's what it was. Do you remember?
Yes.
Like, I remember talking to her about it, but I don't remember what we did.
I know, I don't either. I wish we could. Oh, wait, they're recorded.
How can we access this?
My YouTube?
Yeah.
Where are my videos? Nope, not what I wanted. I don't want my photos. How do I get there? Oh my goodness. Video manager maybe? Ah, there it is. Is it on there?
Maybe. Makes more sense. I was like, there's no way. Like,
you're using the z-score formula for sample means.
But the thing is, if you need like you need 2 values, but we have 5. So which ones would you choose?
So you already calculated the sample mean, which is 160, right? That's the value that you'll use.
Yeah.
And then the other value on the top, on the numerator part, is the population mean, which is what in this case?
Oh, that's right. You need to put the population mean.
It's given in the information above.
Oh, so you mean.
Mm-hmm.
Solving for the mean is 160. So I don't know how we would find the mean.
So 160 is the sample mean. So when you're doing sample mean z-score, you do sample mean minus the population mean on the top.
Yeah, no, I get that, but which one is the population mean?
Oh, so it's given in
this is the one
of question 6. You'll have to go back.
Oh, okay. This makes more sense. I was like, there's no way. Like, I just solved it.
I always forget that it says use the following information to answer the next question.
I know.
I actually have to use the following information.
Yeah, and then we're over here like, I don't understand. Why doesn't it give us anything?
Yeah.
Oh, that's so much more sense. Okay.
You'll find it useful if you write down that standard deviation as well, because that's also part of the formula.
Yeah, because it's kind of value minus mean over standard.
Remember that? So on the bottom part, that's what I was telling you. You have to do another division.
For the n.
Square root of n, yes.
Yeah, for a random variable. Because it's not just a simple.
Well, you're calculating z-score for sample mean. That's why you.
So we already calculated the z-score for the sample mean.
Does that make any sense to you? Medicine. Sure.
Yeah, it makes so much more sense.
The mean is you.
I meant yes.
Okay, so I did the equation and I got negative 2.337.
Mm-hmm.
Is that right?
Your z-score.
Would you round so that it would be 0.10?
And it will hopefully help you. After you read that, let me know what you think.
Oh, wait. I'm trying to figure out how far we need to get into this.
But I think I forgot to divide. So let me try.
Yeah, because I feel like we're close to where we should be, but
I know. I don't want to skip past it.
I know, and I feel like we're so close. It's like right there. Means for all possible samples of size 81 that could be drawn from parent population.
It's really rare because I have two of your faces on my screen right now.
I know. And the weirdest part is I'm hearing it and I'm like, I think you're talking or like something's going on. And then it's like, no.
I know. It's really tripping me out.
Oh my gosh. Yeah.
All right, just
bye. Okay. Oh, because they have. Okay, yeah. I was like, where's the other means?
It's just the x minus 3.5 over.
Oh, I got so excited. I was like, it's right there. Okay. Nope.
So you look at the information above question 10 and find out what's the population mean.
Okay. So I know that's what we just solved for. So the population mean would be 3.5.
Mm-hmm.
Oh, it's coming up.
Unless the sample are given to you and asks you to calculate, like we did a few questions before. Otherwise, the sample mean is just going to be the same as the population.
Yeah.
So complex. Why couldn't they come straight out?
Yeah.
So is it 3.5 minus x over 0.7 over square root of 81?
Yeah.
Standard deviation or sample mean? Or the mean, sorry. Hello?
I thought she froze.
Yeah, I think so too. Could you say that again, Alyssa?
Oh, yeah. So, it's Mary. But it's okay. Don't worry.
Sorry.
No, don't worry. It's good. So would you do 3.5 minus x over 0.7 over the square root of 81 for number 11?
So this one, you're just calculating the standard deviation, not the z-score.
Okay, yeah, we're right.
Or 12. Wait, for 11? Sorry, I'm lost. Which question are you on again?
11.
11? So that would just be the same as the population.
So
The
because it's not
sample
asking
mean.
you to calculate anything, it's just 3.5. You don't even have to put it in.
You literally don't have to do anything.
Oh, I'm
You just
confused.
Look
You're
at
not
the
in the
information,
next one.
put it down. Period.
That's so complex.
I know.
Kind of tricky.
Wait, so I cut out. What are we doing? I'm sorry.
A simple, it's the mean. It's 3.5. So they don't,
Is that it?
yeah, that's it. You don't have to calculate anything because it's not asking you, I forget the way she explained it, but it's not asking you to do anything with it. So it's basically, it's just the sample mean.
Oh.
Yeah. it seems trickier than it is.
Yeah.
Which I guarantee
Right.
is the reason we got a lot of the other questions wrong.
Oh, I bet, because we were reading far too into all the questions.
Yeah, and I'm sure that's what is going on with
I
number
know
12.
it's coming up and I don't want to skip, but I'm
Yeah.
like, come on,
Deviation is
guys.
just 0.7.
I know. I feel the same. I'm like,
Just
I
tell
think
me
so.
how to solve it.
Well,
Is that right?
that question will require a little more than
There we go.
number
I lied.
11.
Not that simple.
that's kidding.
I know, right? We think we're on a groove, and then it's like, nope.
Oh,
So
wait, but
remember, there's a formula for it.
yeah, standard deviation is 0.
Oh, I know what it is. I just remembered.
Same as, no, what is it?
It's the standard deviation over the.
Oh,
This formula all day, okay?
Oh, wait.
It's this one. I think it's this.
It's standard deviation of a square root of n, because that's what
Yes.
we discussed last week. And I was like, why won't this formula come up?
Oh my gosh. I don't know why. It like took us forever. And now that we're here, it's like, yeah, that's what it
That's
is.
because it's the simplest of all of the formulas.
I know.
And we're like, what the heck? Okay, so it's just standard deviation over the square root of the sample size.
Yeah. Okay. Which is
believe in my
15.
faith. Yeah, 15.
Oh my gosh. Literally only took us like watching most of the video to figure it out.
20 minutes later.
Okay, I got 31.123. And so it says round to 3 decimal places.
I'm going with it. 31.123. What is the probability that the sample mean GMAT for SRS of 15 students will be greater than 600? So we figured this out earlier, but I don't remember what we did.
Oh my gosh. This is one of those days where you just do so much math that you can't remember.
You know.
Wait. I feel like it had something to do with the z-score, didn't it?
N over 15 will be greater than 600. Yes. So I think N is going to go in as X. So 15 minus the mean. We've used this mean for so long, I feel like I have it engraved in my mind. 542.3 over standard deviation of 120.54. Solve for Z.
Mm-hmm.
But then you've got to factor in the 600. Oh, it was that weird formula you figured out, remember?
Oh, the 600 subtracted by 542.3 over. Is it that one?
Yes.
Okay.
You need the greater than and the less than equal signs, but I don't remember how to factor those in because remember we had to look up those questions.
I don't. Like, I remember wait, didn't it have something to do with. Like, I feel like I remember it, but I don't remember it right now.
Yeah. So it had something to do with because remember I was like, that doesn't make sense because how are you getting 0.5?
Oh, okay, yeah.
Mm-hmm.
So I think the only thing you would do is you would put it's greater than 600. So.
Oh, but you have the sample mean. So you're going to do the sample mean formula. Right?
Yeah. Sample mean.
Mm-hmm.
Yeah. And I'm looking on the answer key, and they got 0.03. I don't really know.
There was an answer key this whole time?
No, it's like online. Like,
Oh.
I like looked it up, and it has all the other answers on it, and so I just haven't closed out of it.
Oh, I was like, seriously, this whole time there was an answer key? Oh.
No, that would have been really annoying.
I know, it really would have. Okay.
Or maybe it's 0.032. I don't know. Okay, so it would be 600.
We got 600 minus 540
2.3.
over.
Yeah. We've done this so many times, I feel like I memorized it.
I know. 120.54 square root of n, which is 15. Well, your top number. Is it cheating to use Mathway? I don't know. I don't think it's cheating to use Mathway for stats, but I think it is for algebra.
Yeah, I think because the whole point of like moving stuff around.
Yeah.
1.8.
600 minus
854.
532.
Okay, and it's greater than. So I got. Oh, yes. So it is right. So yeah, so you just do the formula and then it's the area, which is 0.032, and that's right.
I got 0.123 when I did this.
You
know what? I did the same exact thing I always do, and I forgot to put the divide sign in the middle.
Oh, okay, yeah.
Yep,
Because if you put the divide, then
it'll drop it. Okay, we still have questions
19, 20, and 21.
And these are the ones we don't understand.
No.
So maybe we should Google these ones and see if we can get like how people did them, because these ones we racked our brains for quite a while.
Yeah. Okay, these are not on this page. Let's see. I'm happy that I could figure the other ones out, though.
I know.
It feels so good to understand.
I know. It only took like a couple hours.
I know, it's fine.
Yeah, that's okay.
Great.
Oh gosh, no. Oh, there's like a million of them. Okay, let's see. The answers are in the question. No, they're not. What does this person say? Whoever said that is not nice. It says, first of all, an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. It also says that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million, and values outside of this range are unusual. That means anything outside of the range of 1.59 to 2.52 is more than 2 standard deviations away from the mean. That means that the mean plus 2SD equals 2.52, and mean minus 2SD equals 1.59. Mean and SD are 2 unknowns. You have 2 equations and 2 unknowns. You take it from there. I hate solving 2 equations and 2 unknowns.
I hate the most when you have to guess. So I looked it up, and it said the answer was 0.233. But I don't know how they got that. I mean, it makes sense because you're supposed to round to 3 decimal places.
Right. It's on Chegg too. So let's see if Chegg explains it. Please explain it, Chegg. It does, but it's not going to tell me on this. Okay.
Oh, no, wait. Question 19 is 2.055. That's what it says it is.
But how do they?
I don't know.
Does no one like to show their work anymore? It's all just about the answers nowadays?
Apparently. And I get it. The answers help you, but it's just not helpful enough.
Yeah.
Because
it's like you can.
Far.
Yeah, and you can only see people working it out if you want to pay for it. And like, I don't want to pay for it. Just help me.
Yeah.
Yeah, I don't know, because I have no idea. I mean, my only thought, because like, I don't know. I have no clue. So I guess with 21, you can do 21. And you can tell that 1.823 and 2.288 are between those two values. They're not on the two values and they're not outside of them. So the only one that really fits is 1.823 and 2.288.
For
21.
Oh, 1.823 and 2.288.
Yeah, that's the one that actually makes sense.
Yeah. I think that one's actually right because even though it's blurred in this one, it shows the last one being right.
Oh, okay.
Yeah.
I wonder if you write these two equations, minus 2 standard deviation equals 1.59. Well, I guess, okay, so you're solving for the mean, but how do you get rid of standard deviation? You know what I mean?
Yeah.
Oh, you know what? If you put it on top of each other, so
then it would cancel out.
Yeah, if you do some ridiculous algebra.
It's okay. Algebra is not that terrible.
Which is why I didn't think about this before, but if you put them on top of each other and you cancel out the u's, or the standard deviations, they cancel, you're left with u's. But I don't know if they multiply and you get 2, or they add together and you have 2u. I haven't done algebra for quite some time. And then you're stuck with adding those two together and then dividing by 2. Does that sound right to you?
You add them. Oh, you mean the 1.59 plus 2.52?
Yeah.
And then you divide by 2.
Yeah, is it supposed to be that easy? Because if it's that easy, I'm going to be really mad.
Alright. Well, the only way to figure it out is to try it. 0.9 plus 0.52 divided by 2.
Is it? It's that easy? No!
Yeah.
Oh, that's awful. But the next one, I don't get how they got the standard deviation, because the standard deviations, if you put them on top of each other, cancel each other out. The only way to get them not to cancel each other out is to add 4.
Well, because now you have the mean of the nitrate.
Oh, see? Algebra.
Yeah. I love algebra.
Okay, I'll give it to you. You can have it. So now you're going to input the mean and you can find the standard deviation. See, I'm more used to it with like X and Y. So if they would have did this with X and Y, I would have been like, sure, great.
Yeah.
If they were like, let standard deviation be X and let mean be Y, I would have been like, great, now I know how to solve it. So then you get 0.233.
Yeah, 0.233.
Yep.
Yep. That's a wrap.
Perfect.
Could you send me the link for the, remember when we were doing it earlier, the thing that calculates the...
Yep, I can send it to you right now.
Perfect.
Let me make sure I do it though.
All right. I'm going to submit this.
Mm-hmm.
Just going to go for it. I'm going to watch the video. I feel like it's not going to be a terrible test. There are things that I probably won't understand. We got a 90 on it.
You did?
Mm-hmm.
Woo!
Killing it.
Huzzah! Okay, I just need to find this. What is it labeled as? Where is it? Not that. I'll find it and I'll get it to you.
Yeah, just like email it to me or just, yeah.
I will. I'll do it right now. I just have to find which one it is because I have it. I just don't know what it's under.
Yeah.
And obviously I was just using it. I just don't remember what it's labeled as. So
Yeah.
found it. But I will send it over to you.
Perfect. Thank you and good luck. You'll do so good.
Thank you. You will too.
Yeah. Okay, cool. Thank you so much. See ya.